And after these 3 hopefully amazing days, what we've had there to finish the summer camp, because he's bringing a really interesting topic. It's architecture and machine learning. So he's having background also in architecture, machine learning, computational design. He was also studying in EPFL. Now he's doing his postdoc in ETH in Design++. And I think it's a really nice topic, how we can also combine architecture and machine learning, how we can learn from it, and also, feel better the space, and combine all these techniques. So we are happy to have him here, and that he can present you his amazing work. Thanks.
Thank you for such an introduction. I would like to just reintroduce myself. I'm Mikahel Johanes. I'm from Indonesia. Bit far. And then I did my PhD at EPFL at 2019. And then I finished like last year, and I did my EPFL Media and Design Lab. So a lot of things that we do are not just architecture, but also about interface, about human computer interactions, and of course our core is architecture. And then I currently do my postdoc at ETH, Zurich, with the chair of Pattern DeWolf and also Xiu Tang. Basically, we are integrating about the potential of machine learning for circular constructions. But the topic that I will bring is mostly about what I did at EPFL. Hopefully you can enjoy. For sure. So the title is Architecture to Machine Learned Representations. I will dig deeper into what does it mean with machine learned representation, because representation is kind of the word that we used to learn already from bachelor, that we draw everything and then we draw we model things in 3D in AutoCAD and also BIM. And I think this is kind of like with the AI, the idea of machine can learn, but what does it mean with learn, and what does it to do with the notion of representation as we know it. So I started my journey in digital or computational design actually 10 years ago, when I do research in my home country in the University of Indonesia before going here for PhD and continue the research career. And in the beginning, it was like the idea of this digital simulations. Basically having we need a kind of copy of our architecture or buildings in computer. So there's a kind of, we create the representation inside the computer. For us, it's a bit different. For us, drawing is for us to understand, but for computer, drawings is for them to compute. So it's not just about like we see the model, but the computer can perform something with the computer, which is we call simulations, analysis, whatever. So this is just kind of like idea that by having BIM model, we can analyze the space, we can do some very specific analysis. Simulation is, it doesn't matter what kind of analysis here, but basically it's kind of expression that we have kind of digital copy of architecture in the computer. So the idea that we can simulate particular performance depending on how we construct the representation. So representation is something that is performative. And then a lot of to do, and I did my research in University of Indonesia, is about complex movement and complex space in complex buildings such as hospital or shopping mall. So it's about the idea that always the idea that can we expand human mind. Such a complex building, it's hard to rely only on intuitions. So the idea for us to compute is also to expand this, like we don't want to miss something, like whether there is like a bottleneck in particular corridor that we miss. So that would be the core idea. And also when I did that research, it's basically about movement and also about wayfinding, about where do we put signages and how we can move without losing on sight of what we're gonna go. And it's basically personally, it's kind of hard for me to do that because basically you kind of have to encode the logic of the way we move and the way we see space into code, into algorithm. So it's a very restrictive in a way, like it's a lot of assumption coming in. And I mean, it works, but also I felt that actually it's a lot of work to do because everything we have to encode into computer programs. And then I came to EPFL and it was 2019. It was the moment where somehow generative AI, we don't call it generative AI yet. It's like machine generated images coming to the industry, not industry, but to this field, and basically kind of changing the notion of actually machine can learn something, and the question back then like whether machine can learn architecture. So this is one of the first project that we did 2020. It's basically we collected like thousands of images facade of building Swiss chalet or open huts, not just chalet but also the huts from SSC, Swiss Alpine Club, I think the name, and basically we clean up. So basically we use what we back then GAN. I mean, if anyone has heard that GAN, generative adversarial network. So it was super interesting because 5 years it was the state of the art of generating images. Now it's kind of like almost archaic technology. But yeah, I mean, basically, it was the moment that we found possibility that there is a way for machine to learn architecture, and a lot of exploration coming with the students back then. So we did it for the studio. Basically, the idea that architecture that we see is not as a static image or photographs. Let's say, I mean, this is a from photographs, but as a kind of multiplication of different architecture coming together, what we try to find what does it mean with Swissness, like Swiss chalezness, like something like that. Like we try to kind of extract that. So these are the work of the students, like they basically create the data set from what we give. They have some criteria, they train their own machine learning, on GAN, and they generate these images and they use it as inspiration or as a sketch for a design. So it's kind of like if it flipped the direction of creation. Before, usually we start with the concept and then we continue with the drawings or sketches. It's kind of we flip that. We start with images and then we kind of try to extract what the concept is. And so, and then we use again machine natural language processing to kind of like process that concept and to see, basically we try to kind of squeeze out the logic of these images and to see what is the recipe of Sicily. So yeah, I mean, it's very explorative, but basically it's kind of using machine as a lens to see architecture, and that lens is basically the representation that has been created by the machine itself, something that is quite different from what we understand as representation. And yeah, it's quite successful. We propose this to we present this in the Seoul Biennale in Korea 2022, I think, and got a very nice reception. But yeah, basically that we kind of like thinking about what if there is kind of design brain. So it's like machine that has a brain. It was before Midjourney, so so we don't yet have imagination that there's gonna be a super user-friendly interface that we just type stuff and then we get images. That they already kind of envision that there will be something that machine that infinitely generate images for you. And then we have a question of what does it mean with authorship and what does it mean with designing. And yeah, this is something that we somehow, it's kind of time machine. Like we go back and to see what actually the innovation is actually being done by the engineers. Yeah, and then we scale up. So this is probably reminds you because we tried to learn Zurich actually. Zurich Altstadt. So these are basically the Google Street Views that we collected in Altstadt area, and basically we tried to see what is Zurichness, and based on that, yeah, I mean this is a long study from here to here, but basically a similar studies that the students tried to extract the essence of this generated images and create a kind of like a twisted images of Zurich Altstadt. So you can see a little bit like kind of like a glitches and kind of funny roof, very interesting. But somehow there's kind of a glimpse of Zurich Altstadt in that in the model. So yeah, I mean, it's just a very fun experience. It's kind of like we are back then feel like we were in the forefront of this field. We continue and we basically try to understand what is the limit of these images. Because before it's a kind of object, it's kind of hot, just a single object. And then with the city, you cannot treat the images as an object, but as a kind of, I mean, kind of Las Vegas strips, as an urban context, but it's a very, still we can see the architecture. But we moved to again to Seoul because we visited Seoul and then see it's actually interesting to see as an urban context. And then there's particular area in Seoul that we call Gangnam, which is popular. And then we're like, why do not we don't do Gangnam Studio? It's Gangnam is very particular area because it is basically almost like they have a very particular structure because it's a block, and you can see it's basically we are not using a machine just to generate, but we try to understand it. So basically we collected the images similar way with Zurich, but we use machine computer vision to kind of clustering the images, like with just by the similarity of the semantic side. And it's quite interesting because you can see like inside is basically the houses and outside what we call the shell, which is basically the commercial area. And there are different characterization of of neighborhood that somehow intuitively can be separated by machines. And the thing is like we don't train this by telling the machine that this is houses, this is shops, this is shopping mall. We just give the images to machine and let them separate according to, it's almost like intuitively separate the images. I mean, it's very difficult to see, but yeah, trust me, it's kind of you can see the differences sometimes, most of the time. And yeah, again, a similar exercise with that scale, because the data is getting bigger as the scale of the neighborhood of the study larger. So the idea in the beginning, the creation is kind of like more like eyeballing, like you basically handcrafted the data. But with this, like even one block, you have like 1,000 of images. So you do this kind of analysis to kind of cluster. So it's almost like data scientist project instead of architecture. So there was a question whether architect should learn data science because somehow the data is, I mean, the notion of representation is equal to data, and then to draw is actually to do statistics. Yeah, something similar to the inline. So yeah, a lot of speculation back then, but apparently these days, what does it mean with architects using machine learning is just put a text in the text box and hit enter, and then you get images. So a bit pretty far from what we speculated, but I feel like that kind of learning or drawing architecture through statistics much more interesting rather than just putting text, because then you actually try to learn what does it mean inside. But still, I mean, as a it's a lab project, a lot of teaching studio, and personally in my own PhD, there was a questions like, okay, all of these are just images. I mean, you only almost like superficial idea of architecture, and you have seen probably here in LinkedIn that you just wrap a paper and then you turn it into either Zaha did or Frank Gehry style. Yeah. Now it's possible. This is much older by Daniel Bolohan basically used the data from one big firm, and then they use. So there was back then like big firm like Zaha Hadid and Coke, Go. They tried to kind of like squeeze out. I mean, in the previous slide, they tried to squeeze out Swissness, Zurichness, Seoulness. They tried to squeeze out what does it mean with Zaha Hadidness, and so they tried to kind of like perpetuate the images of their firm or the identity of design. So it's kind of like almost on the surface, and you still need architect always to kind of think critically what is inside. So this is what drives me to see not non-images, like what does it mean with machine learning doesn't learn just image, but try to learn space. And this is just basically the way we draw architecture, even though now in 3D, but basically in similar principle, basically we draw the walls and then the space is something empty inside. And this is basically the dominant mode of how we draw architecture and model architectural BIM. Basically, we treat space as the empty space, and then we draw the physical things. But I mean, in order for actually, for me, I think to understand space, meaning you have to put the space as a main actor of the representation. So I got interested in this what we call view set or isophysics. It's basically just almost like the volume that we see in one point. So basically this is how it shows, like if you have a floor plan, okay, this is 2D, but you can extrapolate to 3D. But if you have a point and basically you scan and then you see how far you are from that final position, and you basically have a very nerdy representation of architecture. And basically the whole 4 years of my PhD is trying to understand what does it mean with this numbers. Yeah, so please hang on. So I mean, this is just kind of intuitive idea why I choose that kind of representation, because this is kind of de facto the way we actually record architecture right now into digital form. Basically use a laser scanner, and I feel like if you have like vacuum cleaner that also scans your space like that. So I have an idea like what happens if a vacuum cleaner can learn architecture. Can be used to learn architecture. It would be kind of amazing. So this is the idea, but of course for technical reason I have to compress it to 2D, so things get easier and things get cheaper. And I can theorize some of that. So I need some data. So there are like 5,000 floor plans, housing floor plans in Finnish area, and probably you're also aware of there is like a data set of Zurich housing by Matthias Tanfes, I think. I forgot the company, but he was doing a startup and then he collected. Yeah, Matthias Tanfes. And I mean, but back then it was not available to me, this data set, so I just used the Finnish house data set. Otherwise, I would just use a Zurich Swiss data set, which is much more contextual for us. But yeah, the idea is basically similar to, I mean, the logic by machine is like the more the better. So you sample as much as possible this panorama from inside of the building. It's a bit of niche study. I mean, no one's do it. I mean, my paper also only got cited by a few very small community. So this is not really the dominant paradigm of AI right now. But I believe with the advancement of video generation and this kind of like egocentric point of view of architecture, things get changed. But yeah, basically you learn that basically this number is compresses this machine learning, try to compress everything into a single what we call Latin space. Yeah, the question is also what this machine brings to understanding of the space, because it's basically just abstract. I mean, during those 4 years, kind of found the relation, like, actually, the machine cannot understand anything but just differentiate things. They are able to differentiate, and the fact that our ChatGPT things is actually I mean, they have meanings, but actually the computer that have no idea about the words they spit out, but they know that this word is different with other billions of words in particular way. So that's how they develop the meaning. So a similar way we can put that idea of that into architectural space. What happened if actually the machine cannot tell this room, and I mean this room is a classroom or that room is a living room, but it can tell that it's kind of different. And then human basically tell us, okay, this is kitchen and this is that, and then that's where the meaning is coming. So that's why we call it shallow semantic, because the semantic is basically it's not there yet before the human coming. So I'm basically it's a lot of things like about that, what does it mean with typology, what does it mean with semantic, and what does it mean with the way we generate architecture. So yeah, I try to be fast because how much time do I have? Yeah, I have still 20 minutes, I guess. So okay, I mean, remember we basically pinpoints a lot of points. I mean, basically record every taking a picture of your house from different point of view, and the idea is that whether as a collectivity can it somehow inform typology, and Zurich is always a thing, because I think this is very old study by Aldo Rossi when he was here. It's basically and the interesting part, they already try to do this kind of statistical analysis of, and then the idea that machine learning kind of scale it in certain way. So the question back then, like, can we see typology from machine point of view? And basically machine learning is also kind of a form of essentially compression. So basically it compresses this data into, so by meaning compression, meaning it loses some information but maintain the most important information. So I won't go technical with what does it mean with machine learning, this kind of particular machine learning, but basically it's kind of what you call autoencoder. You encode and you decode. You encode a very small amount of information and you try to decode. So the idea is basically by compression you will learn something. And yeah, again, the studies basically try to differentiate these sample spaces that is learned by the machine, and we call it self-organizing map. It's basically self-differentiating, basically putting similar things together and different things far away. And I use that as kind of fingerprint. So it's still the idea that what happened if we put a placeholder about a label of a room without knowing yet the room is. So yeah, a lot of exercises basically try to test whether this hypothesis is correct or not, and there are different way of seeing the space. I would like to emphasize this because usually when we see this kind of floor plan, we see as if we are inside, but if you use computer vision, you see it as kind of like Chinese letter. You see it as a strokes of whatever, without understanding of what this floor plan is. But by using this kind of, so you read the floor plan from inside of the floor plan, not from outside of the floor plan. And particularly, I found that the differences is subtle, but basically you can tell the directionality, like the amount of windows and what the complexity of the space. It's basically a way to kind of like, let's say we have 10,000 floor plans, how do we organize that? And of course, you don't want to eyeballing one by one. Okay, this is maybe this is maybe that. So the use of that is kind of like relational criteria. Yeah, we can organize that, but then what does it mean? Whether the machine can really understand what is inside. So, okay, back into this kind of ChatGPT. The hypothesis technically is about semantic that is distributional. So basically, I think this is kind of. Do you remember? There's also this analogy idea that if you have king, queen minus gender, and then you get a man or something like that. So there's certain analogy. So machine learning is basically analogy, a huge analogy machine that tries to create links between different things together. And I would like to kind of teleport that into, I mean, in the space, like we have this kind of meaning, you know, like above, below, inside, outside is, and that meaning is almost like kind of opposite. So what I mean opposition is like we are always inside, outside, top, bottom, small, big, sharp, and somehow the idea is whether we can create meaning just based on that constellation of opposition. And yes, somehow with this kind of machine can understand that whether you are near a corner or you are in the corridor or not, whether you have a space or not. So it's very simple, but it's kind of like a baby step to what really to answer the question whether machine can understand space in a way that it doesn't understand as we understand it, but it's basically just a huge machine that can understand differences between the different things in a very small. So this is kind of like the left is basically the vector space, like this kind of like collection of oppositions. And this is kind of like the heat map that's showing these oppositions. So like you can detect where is the opening, where is the like in different direction, and whether you are near to certain wall and whatnot. So it's kind of like a field of machine feeling in the floor plan. And it gives me an idea whether a machine can be used to analyze something that is subjective. It's not that something is not like square meters, like you have 3 square meters or bathroom is small, but whether the machine can already have an intuition that is small, and then you put a window and then suddenly you feel more spacious, but you still have 3 square meters bathroom. So those kind of things that I'm really interested is not like machine as calculators anymore, but machine as kind of like to link our intuition into that. And because I don't train my machine with any human fabricated data except the floor plan, so basically these differences are purely created by the data that is in the floor plan, meaning it's kind of like imagine that alien has no idea of whatsoever of our world, and then just boom, and then suddenly it understands how the differences of our culture and whatnot. So it's similar like that, like tabula rasa approach. And the interesting part, because I trained the machine with just this boxy houses of a Finnish housing, and then I try what's happened if I bring this machine into a very completely alien architecture that is not it's not the training data that, and this is like just a cut of the Palladio, which is always in our architecture textbook. So that's why not? I mean, there's always this Miss Pandero and the Palladio. It's always that. So yeah, and yeah, so for a reason, we still understand a little bit of that, like the main axis. Uh, and yeah, basically a bit limited, but it's also give me an idea of like comparative analysis, but also as the idea that machine can generalize beyond the corpus. It's also interesting because it's a bit cultural extrapolation, because let's say you live in Zurich only, and then you go to, I don't know, South America, and how do you see the architecture? Right now, it's very difficult to hypothesize that because everything is connected. But imagine, I mean, 5 years ago, like when you see amazing work, and whether you can still appreciate the architecture that you never see. Yeah, just a bit extra thing that this is a way of analyzing whether you're gonna have a weird floor plan or not. Like, it's basically a way to see what we call typicality or diversity of the floor plan. So, with this kind of intuition, I can somehow code the machine in other way. Okay, if you have like more frequent type, and then you put in the center, and then you put the one that is a bit weird, I mean, it's a bit out of distribution, we call it, on the left side, and the one that is under distribution is on the left side. And yeah, I mean, it's another kind of like a way of reading floor plan, not as one by one, but as like 10,000 floor plan at once. So yeah, machine is about number game. I think the idea of scalability, like how can we scale intelligence to with machine, is always the entertaining aspect of this this idea of machine intelligence, like to copy intelligence that we have, but also they have some intelligence that they have. So yeah, that's this is the last thing in my PhD. Is basically it's about just analysis, but then like with this understanding, can we also generate architecture, and what kind of architecture that it can generate? So this is a very old way of generating architecture. Basically, back in the days, the idea of discrete is already there, like modular architecture. By having model, you can have like Lego. But also there's another modularity. It's not modularity of shape, but modularity of concept or of rules. So maybe some of you, or maybe some in the school, same grammar is kind of that kind of rule based machine generated images. So this is kind of paradigm how we generate architecture is basically very modular and rule based. And my problem is that with that generation, like the digital generation, is like you eventually have to discretize, like you have to make things in a unit. But then with this kind of machine, magic machine, that can compress architecture and then expand it again, and there is a notion of like we not discretize architecture in the reality, but we discretize architecture in the latent space, which is the machine learned representation. So it's a bit technical, but it's also philosophical, because the modularity is not exists in the space that we see, but exists in the deeper conception of the architecture. So so it again, to learn this shape, this shape of isoface, and we can indicate which one is the wall and which one is not. And by accumulating that, basically we have some sort of point cloud, but in 2 dimension. So the fun part is the architecture, and it learns, and then it have a catalog of, let's say, like kind of a code, like 1,000 codes that basically try to describe this data frame. But that set is kind of like a very compressed form. Let's say you can describe that shape in only 16 numbers. But those 16 numbers are drawn from a limited of 1,000. It's basically a kind of brick. And then there's a little bit of test. Okay, I should rename this, but basically, this is a test. Like this is when you quantize that. I mean, when you do this kind of technique, and this is when you don't. And apparently it can represent the space better. Basically, this is different machine try to learn, and the one on the right side, sorry, yeah, the left side are the one that use this technique. So I have an idea of what happened if we bring this machine walk randomly in the floor plan. So basically, like having a video camera and walk randomly inside the building, and basically we're gonna have these numbers. It's basically like a text, basically just a sequence, and it's a very predictable sequence. And we use machine learning that is similar. So yeah, basically this is the way I see it. Like when you move, you have particular number that express the movement and particular numbers that express the shape of the space. And yeah, you walk through all of this floor plan. That there's like 5,000 of that. The idea is like if you walk enough, you basically can imagine that you walk in that space. And then basically this is ChatGPT. I mean, it's ChatGPT is this basically it's transformer that learn sequences. Basically, they try to learn this sequence of numbers, and then from that sequence of number we can encode back, and then we can recreate the space that they walk into. And then now with the video generative model, actually we can do that in 3D. With much more expensive computational resource, of course, but that's possible. This is just so yeah, it generates something. But it's finally because also the machine have kind of limited attention. Let's say you walk 30 steps and it forgets the 30 steps that you. So somehow you create a kind of dreamy architecture that you replace. It's kind of overlay together. Let's zoom in a bit. Like, I mean, you can see like this is kind of like the bathroom or kitchen, and this kind of like maybe entrance, or I mean, there's kind of typology of the houses that get remembered. But also because of this perpetual forgetting, it create this kind of collage of space, a kind of dreamy space that you walk outside and then we walk inside and the space changes. So, and it's kind of incoherent in some sense, and also combine different floor plan together. So it's almost like similar with the images that we see before with the Swiss, that it combines different huts together into one animation image, but instead of animation, it's basically translated into movement. So yeah, I'm not sure it's useful, but I can imagine if we create a kind of open world game, that would be interesting too. Right? Maybe kind of like, but sometimes, yeah, I mean, the thing is like in the data set, there is no, I filtered enough, so there will be no boxes like that, but somehow to slip out and to get trapped into its own space, so it cannot escape, and sometimes also just trapped in a limbo, and then not, because the way it generates is basically conditioned by the space that has been generated before. So if you lose the context, suddenly they lose the ability to generate. So it's almost like when your mind is in a cloud. And yeah, there's a bit always a love with Palladio and Nisfandru, and the question is like, okay, you have been trained this machine with 5,000 floor plans, and I have like this 10 set of floor plans from Palladian Villa. The idea is whether the machine can copy that learning from these houses to just what we call few shot learning. So basically just to, okay, you have learned so much. Now this is Palladian Villas, but I only have 10 of those instead of 5,000. Can you learn something? And it does actually. So the machine is not just copy the data, but actually learn something from that, even though it's a very small scale model in comparison to the model that we have commercially. But it does prove that there is something. But again, it's not create or learn the whole Palladian villas because simply, yeah, I don't have budget to have such a long attention span for the machine. I mean, technically, yes, you can, but this is also interesting fact that it's kind of have a local consistency but global in coherence. So imagine, I mean, when we have ChatGPT, not ChatGPT 3, but ChatGPT 2, that when you ask them to write paragraph and then it's kind of like nice as a sentence, but as a whole paragraph, it doesn't make sense. So it's similar, like it's a similar condition with that. And sometimes get overlay. Yeah, it's a kind of an architecture itself that I feel like, and then I go even further, like what happened? We just tell them like these 3 floor plans, and can it generate something? And it does. Like it can create this kind of fluid dynamic movement, and then also generate a flow walls along the way. But somehow, because of the data is very small, only 3 floor plans, basically memorize a little bit of what it is. It's not like really generate something new. Actually, you see like this very iconic features of one particular, I think that's not person, Berlin House, I think. So this video like showcase like how it actually generates. So it's a step by step, and you see like it's almost infinite actually. It's finite because we stop it, but if we continuously generate, it will continuously walking. It's what I call wandering machine. So it's a wander through the representation of architecture that it learned. So yeah, it's a good exercise. Enough for me to finish my PhD. But it's almost like this it's technical, but also more like theoretical in a way that how we can conceptualize architecture in the age of machine learning, because somehow there are things that are different. It's not like we don't see architecture as a single entity anymore, but as a kind of collection of things. And technology moves, but I think the idea could be retained in whatsoever, like basically we don't see architecture as a singular but as a collective. I mean, I think change also our idea of what does it mean for being an architect, because back then we were like maybe saved by the notion of a star architect that have very unique, but it's more like so at the end of our PhD, we culminate the work of the lab in an exhibition in Professor Pavilion, and what we call artificial architecture. So yeah, it doesn't. Yeah, this is like the 3D printed model that being generated by this studio. So this is my last slide. So it's like to showcase like how machine see, how can we use machine to analyze, prompt, and to generate architecture. So yeah, you saw this one for basically again, and yeah, again Zurich. Okay, this basically is like also the capacity of machine to see everything is like also a question of urban mining, like can we use computer vision to kind of like scanning the city and then get what materials that can be used. And so yeah, just besides like yeah, this is like the whole idea of this and yeah, the whole 3D print is yeah, we see this as kind of like machine that continuously learning and generating architecture, and somehow architect is more like on the pilot part, that's the kind of directing. Yeah, we explore explore also text to image model, and we see whether architecture can learn particular architectural vocabularies. So yeah, that's it. Thank you so much.
I think it was interesting, and also to see your 4 years of this crazy research, because it has, as you said, not only technical part, but it's also a lot of philosophical part and so on.
Yes.
It's really hard dilemma always.
Yeah, I mean, we are not computer scientists, but we are like architects that applying machine learning, and then we kind of like always like we don't want to be just the consumer of the product or machine that being produced, but we also want to critically engage with that. Of course, it's not always easy, but yeah, luckily we have couple of resources that enable us to understand, and also I think also right now with with machine expand our capability of doing some manual work like coding, that really accelerate I think those kind of explorations. I mean, back in days, we have to learn the hard way, like really go through the documentation, asking people and learning by ourselves. Yeah, but hopefully, and I'm open to any questions or thought, or just also maybe I want to hear, because it's very small audience, so I would like to know what you are working. And
I would like to ask, why feasible and pacifist? I said it before.
yes, I said it before because in the beginning when I did before I did my PhD, I already have kind of obsession with space, not the architecture, because I feel like a lot of people already have put attention into that, but less attention to space, because that's where actually the human lives, while the architecture delineate or limit that. So I want to kind of like, okay, this is interesting, first of all, but back then this isophase is very limited into just analytical and a very, I would say, limited formulation, like mathematical formulations. I mean, it's a part of the field that we called space syntax back then, and they go into this relation of like behavior and space, and they try to model behavior based on formulations. But so I saw opportunity because, in a way, it's a field itself, that I used to for analyze the notion of feasibility. Basically, it's a mathematical formulation, but machine can see images, also can understand images is two-dimensional data, and isophase for me is one-dimensional image. And I just see a technical opportunity, first of all, pragmatically, but also, again, the question of machine understands if we ask whether machine will understand space, what is the proxy? Is it through images only, which is using camera or panoramic camera? Or actually, what is the modality of machine that we cannot have? Basically, these laser scanners, it can detect distances. And I was like, this is probably how machine see. Machine vision is not limited into just image that optically projected into the eyes, but also it has the ability to precisely measure the depth. Well, not, precision, depending on who you ask, because for some people, 5 centimeters tolerance is good enough, but for some people, you need 1 millimeter tolerance. But yeah, that's one way. And then I feel like isophase is kind of effective way. It's kind of conceptualization of these laser scanners in very low dimensional space. So it's an effective way to study both practical and also conceptual. So without losing grip on the technicalities, but also can expand theoretically to larger context, which is 3D.
Yeah, I was fortunate that you started with facade with pictures. Now you're inside the building.
Yes.
The next is outside for the city.
So
The ISO is running in Zurich.
So yeah, right now, actually, a lot of, again, like the technology changed, but the idea is the same. Right now we have a good enough model that can predict 3D out of pictures. So somehow with enough data, machine can tell what the volume of the space just from an image. And then that somehow change this expensive data collection with laser scanner with just only we can just use panoramic image to go around inside or outside the building and create this like 3-dimensional representation. Of course, this is the thing about machine learning and the previous technique with precise modeling with PAZ or BIM. You somehow I feel like there is kind of like you sacrifice precisions with context, meaning with BIM you can model everything as precise as possible to micrometer or millimeter at least, but you can only do that much. I mean, you can only see what you model inside, and with computer vision and machine learning, you can record a lot and you try to extract as much possible information from that. But for a reason, I don't think you're gonna have 100% precision because of, I mean, the statistical nature of the data and the uncertainty and whatsoever. But somehow you get a context, and then you can learn a lot from that. And right now, a lot of more research is going like scan to beam, and it's basically the idea to translate sensorial data into useful information for a digital twin, for example. So it's kind of engineering game right now. Like, how do we improve the the accuracy to the tolerance that is practical enough to be used. But again, I think it's very interesting idea because right now machine can sense, machine can perceive. So we create BIM model that is super comprehensive to the point that there is no way people can manage by itself or herself. There is no way human, because the idea of digital twin will be only useful if also reflect reality in real time, or at least, I mean, if you create BIM model, boom, and then the building evolves himself and the BIM model stay the same. I mean, ideally, I mean, yeah, you want to incorporate with the management, the building management, so you get like really insight from the model. And we had a discussion with some industry partners that, yeah, that's actually the bottleneck. Like, there is no way to manage this super detailed model. I mean, if you only have a sketchbook, it's easy. If you only have an Excel sheet, it's easy to put numbers every day. But if you have such a complex BIM model, and then how do we maintain the information and reflect that? And yeah, robotics and sensors is crucial in linking the virtual and physical. Yeah, I forget again the question.
It's fine, I like the answer.
Yeah.
And now that you are coming, so you are having a lot of steps in your back without this crazy boom what's going on now with the commercial models and all the intuitive and user-friendly things. How you see the development? Because you have a rough road behind you. Now you see also that something is changing, and what you see, what's going on, or what is happening, or how it will change also.
What is interesting, I mean, every single week or I open the the usual platform that I to check the or at least every 1 month there'll be a new model coming that somehow surpasses the previous model. Yeah, but for a reason, I think right now there is like this leaderboard racing, but the core idea is the same, no? So I'm not too much bothered by that progression because what is important is the idea, not the technology, and the technology can adapt, or of course idea get informed by technology, meaning it's a kind of what you can afford. And right now we had a vision probably in this kind of next 2 years they're gonna be this way, but the ultimate goal of actually this kind of artificial intelligence is actually can they understand architecture. So a lot of research is going into spatial understanding, which is interests me a lot because that's actually I think the proxy to what the to architectural understanding. But architectural understanding is a complex. It's not just the space. It's also about the culture. It's about the nuance about the people. So it's gonna be always combination of everything. And yeah, this machine is just layer that you keep adding. It's almost like the ingredients that you can remove and add it later, especially with the notion of agentic AI. So it's almost like you have unit of different machine learning or AI that works together. I mean, if there is new model coming with a better performance, you simply just need to detach the old model and then adding the new model that has a better performance. The question is like, how far we can improve this performance? Is there any limit to this approach? Can we really rely on data-driven method, meaning basically machine learning is basically learning from pure data, and basically the logic is that from data you can generalize. But I think right now we already see what we call a data saturation, that no matter how much amount of data that you fit in and then how big the model that you scale, somehow it's plateau, the performance not increase anymore. So the question is what is missing? Is whether we need some again human engineered knowledge being put into the machine, or I don't know. I mean, I hope somebody can answer that. Yeah. But again, the question is like, what does it mean for us, for architects, for designers? Whether I mean, there is always you should learn AI, otherwise you. I think yes. I think I'm not like. We should have some literacy of what is happening. And I think it's a tool. It has different logic, and then maybe I feel like the logic will be different with us. So the architecture probably will be different too. But what I mean with different, I hope it's for the better. Meaning, I mean, our industry is not the best industry in the world, no? Like, we consume a lot of energy. We destroy a lot, and we use a lot of resources, and so that's why I kind of I'm trying to apply this knowledge of machine learning and AI for what we call it like circular constructions or circular in architecture. Basically, we try to building less, and we use, I mean, usually technology is about more and more, but can we use technology for the less? Like we use technology like smart enough, like we use AI, it's kind of like I think the fact that there is this theory, I mean like we love simple things and then we destroy a lot because that's the simplest we can do, that's the easiest. And can we leverage the capability of machine to do the hard things for us to make a decision that is good for us? For example, like yeah, just to find materials that fits for this building for the next 10 years. It's very easy to click the catalog and this is gonna be my this is gonna be the windows that I need. But is there any like windows that we can reuse or we can use somewhere, or yeah, something like that, that probably I think machine will help us to do something that we don't want, no? Like that's basically what machine does. Try to do something that is not really our appetite of doing. Yeah. So yeah.
No question.
Yeah. Thank you for hanging, standing with me. It's not always easy to digest.
So you're sharing.
So I stop
I will
here.
It's really easy to now. Yeah, yeah, yeah.